I am Ramakrishna Kalluri, TA of Ganapati sir. Today we are going to discuss about binary classification task using Pytorch framework. Okay. Usually the classifications can be, we can call this one as multi-class, or even you can say restrict yourselves to binary class. Even binary class can also be thought of as multi-class, where class number is equal to 2. That's it. Okay. We will be having several images like n related to n number of classes, and we just have to train a model in such a way that whenever you give a new image to this particular model, that should identify as a particular class. That is the whole target of this entire demo. For this one, we are just using downloaded some Kaggle datasets that containing histopathological data. Where I will show you where exactly this data can be downloaded and how to download this data and how this data can be downloaded into the Google Drive. And from that particular directory in this particular Google Drive, we can open a Google Colab notebook and can practice this entire code. Okay, whatever I am going to do now. Basically, in this problem, we are just identifying the images, either normal versus malignant. This is the basic task. This one can be, this whatever code we are going to develop, that can be useful for grayscale images, or even color images can be given as inputs, and create an algorithm to identify metastatic cancer in small image patches taken from large digital pathology scans. Before that, let me give you some idea what exactly meant by histopathology. People who suffer from cancer, mostly they will undergo some diagnosis, either CT or MRIs or some regular diagnostic scans. After the scanning, doctor will identify that maybe there are a chance of a cancer, so that they just take biopsy from this particular tissue sample wherever they find. Suppose if it is a breast cancer, they will take a tissue from the particular breast area where exactly it has been identified as chances of cancer. Okay. So after taking this particular tissue part, it will be taken to pathological lab, where in that particular pathological lab, they are going to make it into several slices, and after making it into several slices, they will keep it under the microscope. Under the microscope, they will examine the particular histopathology image. Basically, histopathology means, histo means tissue, pathology means disease. Okay, where we call tissue related diseases, nothing but histopathology. Let me show you. Just open a Kaggle account. Just go and type this one, kaggle.com. Suppose if you are a new user, it will ask you to create an account. After creating this account, just type this one, like histopathological cancer detection. Okay, in the search bar, histopathology cancer detection. Here you can identify this particular data set where histopathology cancer detection. You can observe here these microscopes. Under these microscopes, these tissue slices will be kept under glass sliders, and glass sliders will be taken into observation. After this, since the evolvement of digital scanners, these glass slides containing tissue slices will be scanned, and the new histopathology level images will be developed. People in general call them as whole slide images, where it is, in general, the whole slide images will be around some 100,000 cross 100,000 pixels. Okay, but handling these data sets is very difficult, and each image contains at least like 4 GB or 2 to 4 GB we can call. So but in general in computer vision domain, most of the times we will use MNSIT data and CIFAR data. Depending on several problems, we have some go-to data. Like using this data you can experiment a lot. Okay, similarly when it comes to medical image analysis, if you want to do some several experiments using some CNNs or CNN related tasks, most of the times they have come up with something called patch chameleon data. Where patch chameleon data is nothing but it has been extracted patches from chameleon 16 data. Chameleon 16 data I will show you. Chameleon 17 grand challenge, you can see here data. Okay, I will show you. Go to this particular data. Here you can see these histopathology images are like large slide images. Okay, among these kind of images you can see like very huge images. Okay, from this particular chameleon challenge they have downloaded the data, named it as patch chameleon data. It is kind of a go-to data, like you can experiment so many things in related to medical image analysis, where instead of from this entire 100 cross 100,000 data set, they have extracted patch images like small patches. I will show you the entire data set patch images, where these patch images sizes are like 96 cross 96. Okay, you can see they have made extracted patches from this entire slide image containing 100,000 by 100,000 pixels. Now several patches of size 96 cross 96 has been taken out, and they have generated this new data set called patch chameleon. In this particular Kaggle competition, they have again made some changes into this patch chameleon data set. Be confused what exactly patch chameleon. This is what I am talking about, patch chameleon data sets. Okay, PCAM data set. Okay, where most of the in this particular Kaggle competition, the data set which we are going to see, most of the times this entire data contains only normal images and cancer images. Okay, if you type in in Kaggle, you can identify this like this. You can see here the data description. You can see here there are two folders containing train and test folder. Here you can see test image. Okay, I have downloaded this entire data. See here, suppose. See here, you can see images like this. Okay, that is the data set we are going to talk about. And they have divided the data set into something like, suppose by taking all these 96 patches, they are converting into something like normal images and cancer or metastasis images. Okay, where these normal images are declared how means, suppose if you take some 96 cross 96 size image, and if you take the in between 32 cross 32 pixel patch inside this one, in case in this entire pixels like 32 cross 32 pixels, in the center pixel, if they identify it as a tumor related pixel, then they are considering this one as a metastasis or cancer related image. I mean cancer belongs to metastasis, whereas suppose if this particular pixel belongs to something like a normal only, then this entire patch has been termed as normal image. Okay. In short, this this Kaggle data, whichever data set we have, I am going to show for the coding. It has been downloaded from the or has been extracted from the patch chameleon data set, where in this particular data we are having several images. All the images are containing only 96 cross 96 size, where for each 96 cross 96 image they are going to named it as normal images and metastasis image, metastasis cancer related image. Metastasis is not like benign, it is really cancer only. Okay. Where in this particular pixel, if they identify in the 96 cross 96 patch, in between 32 cross 32, if they find out that this particular pixel belongs to normal image, then they have named it as a normal. Suppose this particular pixel belongs to tumor or metastasis, then they have termed it as an entire patch as a metastasis. This is how this has been taken out. Now, first of all, let us go and download this data. Okay. Suppose in your Google Drive, just create a particular folder, and in this particular folder, earlier these files are, assume that these files are not here. I just have only Kaggle JSON file. Okay. Where exactly, assume that I don't have anything else here. I just have only this particular file. Okay. This I am saying this all this so that you can directly work on your Google Drive itself using this Google Colab. No need to do any installations in your local computer and everything. Okay. To download this entire data set that is available in Kaggle, you can directly download into NPTEL, where this data set can be seen here. Like suppose see, train folder is there, test folder is there, sample submission CSV. Okay. Now if you go to this Kaggle competition, where you have data, here you can see test folder is there, train folder is there, train underscore labels.csv is also there. Okay. All these files will be downloaded. Don't worry. I will show you how to download this entire data. First of all, create the Kaggle account. After creating this Kaggle account, you can go here. Okay. Here you can see this account. Okay. After going here, you can see here, create new API token. Once you click on this one, you will get a Kaggle JSON file. Okay. Just download this file into your local drive, I mean your computer. After saving this file, after saving this file, whatever I asked you to create a particular folder in this Google Colab. Okay. Upload this Kaggle JSON file into this drive. Okay. So assume that we have this Google Colab file and only Kaggle JSON file. After creating this one, my job is to now download this data. Okay. To do this one, just go and copy this particular API command. Okay. Just copy this API command to the clipboard. Then go to this file. Just type these things. First import OS. Next os.kaggle directory. It is more or less like where exactly you have stored this entire. Suppose here I am using here NPTEL demo in this drive. I will show you without any confusion. Import OS. It is taking so much time. Okay. Mounting Google Drive. Just Just refresh here after typing on this one, mounting Google Drive. Next, take to that particular directory. Here I have named it as a NPTEL demo on binary classification. Drive NPTEL demo on binary classification. Just open this particular directory. Assume that test train these folders are not present here. Only you have untitled this Python notebook, Jupyter notebook, and only this Kaggle JSON files are there. This histopathology cancer containing .zip file is not there, sample submission file is not there. These two folders are also not there. Just assume that one. Okay. After the, suppose I want to this Kaggle environment where exactly I stored this Kaggle JSON file, I just go to this particular folder path and you can see the copy path. Just type that path here. Okay. After giving the path, go and type this particular present working directory to CD indicates change directory. After changing the directory to, it will convert it to present working directory. If you type that one, you can see this one. Okay. Next, our job is to just download this Kaggle dataset. Whatever I asked you to type, to copy here, suppose I have already told you to copy this particular command, API command, and type that particular command here. It is with respect to you. Okay. Like here, competitions, download. Okay. After this, you will get to see it takes some time to download this data. After downloading this data, you can this particular file, histopathological cancer detection. That is what this file is. Go and see your drive. You can see histopathological cancer detection.jpg will be placed here. Assume that while I run this program, you have only this particular notebook and only Kaggle JSON file. After running this particular line, like Kaggle competition download C histopathology, there, then you can see that this particular zip file will be created there. Okay. After that, my job is to just extract this file, like histopathological cancer detection.jpg, so zip file, so that once you extract that one, you will get to see train file, test file, and submission.csv, and another this like train labels underscore csv. All these files will be generated there. Okay. So to do that one, what I am doing here, just this is the command I will use. Okay. Just type this one, unzip. Since we are already present in this particular directory only, like this folder, so it will go and find whichever zip files are there and the zip files will be extracted. It takes some time. Just have some patience and run this particular line into your Google Colab notebook. Then it is done. Okay. Next, after that, you can see all these files. If you refresh this folder, once the extraction of the zip file is done, you can see train, test, sample submission, and train CSV also. Labels of the train. Okay. Like this is how whatever files I have here, all these things will be provided there. Okay. I hope everybody got it. Just I will repeat the steps. Just go and create a Kaggle account. Once creating this Kaggle account, just go and type this one in the search bar, like histopathology cancer detection in the search bar. Once you do that one, go and download your Kaggle JSON file. To download that one, just go to this account. After going to this account, here you can see create new API token. Once type this one, you can see this JSON file will be downloaded onto your local computer. Once it is downloaded, just go and create a folder in Google Drive and upload that particular Kaggle JSON file into this Google Drive. After that, again go to your open your Google Colab notebook. There just follow whatever instructions I have told. Okay. Your one more thing to notice is just go bring this particular API command. Maybe it gets varied from one competition to another competition. So depending on here in this particular competition, you can see this particular command here. Just copy API command and upload here. Just paste this command line here and you can wait for some time. This histopathology.zip will be downloaded, and after that it is your responsibility to extract this particular file. Once you extract that file, you can see that these kind of folders all are here. I hope everybody got it. Till now we are clear that we can directly bring the data from Kaggle notebook to Kaggle dataset can be directly taken into our Google Drive. After taking into Google Drive, now the entire dataset has been downloaded. Now our job is to develop our algorithm to classify entire images whatever are given to us. Till now we discussed about how to download Kaggle dataset and creating a folder and how to load the entire Kaggle dataset into our Google Drive. Okay. Now let me tell you how exactly they made classification tasks in general. There are two ways. Usually assume that classification tasks exactly in what way problems are given. Assume that I have some 3 classes, then I have a folder containing all the images related to class 1. Similarly, I will have another folder containing all the images that are related to class 2 and another folder that contains all the images that are related to class 3. Sometimes they will give the class name as a folder name here. Assume that here, suppose I have folder name is class 1 only. Inside this folder, I will keep all the images that are related to class 1. Okay. Similarly, in the second folder, I will keep all the images related to class 2. Similarly, I will keep all the class 3 images in a folder. This is how usually classification data problems are given. Okay. Likewise, we will be given 3 folders containing 3 classes of dataset, and they will ask us to prepare a model that will take the new input and predict that particular class. That is how. This is one way of defining the problem. Okay. Second thing is, we will be given a entire folder. Assume that it is a data folder. Okay. In this particular folder, assume that there are 1000 images. Okay. Out of these 1000 images, each and every image belongs to a particular class. Assume that we have 3 classes. Assume that I have 3 classes. Okay. That means I will have here all the 1000 images. Every image belongs to one of these classes. Okay. In a single folder, we have the entire training data set. I mean all the images where every individual image belongs to one of these particular classes. Apart from that, we will also be given a CSV file or a Excel file that contains like this. Okay. Here on left side, name of the image, file name of the image, and here you will be given class. In general, all the Pytorch frameworks or TensorFlow frameworks mostly assume that class 1 belongs to 0 index, class 2 belongs to 1 index, similarly class 3 belongs to 2. Suppose I have some 9 classes, at that time I will have 0 to 8 numbers. Okay. Suppose n is my class number, then class index or class belongs to 0 to n minus 1. That is how. Suppose in this Excel sheet or CSV file, you can see the image name here, image name of the file here, and to which class in particular class belongs to, this particular image belongs to. Let us assume that here I have a folder containing 1000 images. Out of a single, I will take one image here. That particular file name will be provided here. At the same time, class also will be provided here. Assume that here in this discussion, I am talking about 3 classes. So all the column values will be something like 1 0 1 2 or 2 1 0 0 1 0 2 0. Likewise. Okay. Left side we will be having file names of the images. Okay. This is the usual way in which you will be given classification problems. This is first way, where you will be having each folder containing images, all the images. Okay, I mean class 1 images belongs to a particular folder, class 2 image belongs to a particular folder, class 3 image belongs to a particular folder. Similarly here you will be having a single folder containing all the images, and at the same time you will be having some CSV file, where this CSV file contains file name like image name and the particular category to which it belongs. This is how the data set is provided, either this way or this way. Now get back to how exactly we should plan this particular classification problem. In general, any deep learning task, especially like this classification task, we are just going to follow these steps. Okay, these are the key steps that should be followed by anyone while solving this particular classification problem. First one is exploring the data set. Second one is creating custom data set, splitting the data set. Splitting the data set in the means you just have to split the data into trained data, test data, validation data. Okay, because we will train the model using this trained data. While training the model, we have to tune the hyperparameters in such a way that model should not be trapped by either overfitting problem or underfitting problems. That is where while training the model we will use validation data. Okay, by using trained data and validation data we will come up with a particular deep learning model. Once the entire training is done, we will use this test data to produce the generalization error of this particular model. What error this particular model works. Okay. Next thing is, first thing is exploring the data set. Second thing is creating a custom data set. I will tell you what exactly this mean by this one. Custom data set, splitting the data set, transforming the data set. Okay. In general, while we are doing deep learning problems, most of the times models are prone to overfitting problems. To tackle this one, we are going to apply data augmentation task. Data augmentation task. That means suppose I have some 100 images. I just want to make them images into something like 1000 images. I will use some basic image processing techniques where I will apply those image processing techniques on these images and I will generate new images. Likewise, whatever data I have, I can extend it to some more data. That is the main goal of data augmentation. Using this transforming the data, you can use data augmentation step. Okay. Next thing is creating data loaders. In general, I will tell you each and every step. Just instead of, suppose I have some 1000 data points, instead of feeding all these 1000 data points into the model, we just provide this data in terms of some chunks, like 4 every time, like 8 images every time, like 12 images every time, or 10 images or 16. Likewise, we will divide the entire data set into several batches, we call. Instead of, because GPU will be having some limitations to deal the data. Okay, memory. Usually people go for either feeding each and every data point or all the data points at an instant. But both these strategies are bad. You just have to go to feed the data in terms of batches. This is very good step. Next thing is building the classification model. This is where our CNN algorithms we will use, how to design it. Here we have just used a single model, sequential model. Next thing is defining the loss function. What exact loss function we will use, like stochastic gradient or ADAM or RMS prop, something like that. Okay. Sorry, I'm wrong. While defining the optimizer, we will use something like ADAM or gradient descent or stochastic gradient descent or RMS prop, like that. Okay. While defining the loss function, depending on the problem. Okay. If I am dealing with a linear regression problem, I will go for mean square error as a loss value. Now it comes to classification problems, I will go with either binary cross entropy or cross entropy loss. Binary cross entropy is supposed to have 2 classes, cross entropy is in general for n classes. Okay. Next thing is training and evaluation of the deploying the model. Okay. I will train the model and I will deploy the model. Next thing is, last step is model inference on test data. Whatever test data we will have, we will use that model. I will feed that test data into the model and everything will be done. I will generate the testing error. That's it. This is the whole program. This is the whole steps. Like first we have to explore the data set. Second thing is creating a custom data set, splitting the data set, train, test, validation, transforming that most of the time belongs to data augmented stage. Creating data loaders. We have to load the data in terms of batches instead of loading the entire data at an instant. Next we will go for designing the building classification model. Next thing is like defining the loss function. Like if depending on the task it is a classification task, we will go for cross entropy here, something like binary cross entropy. Now coming to optimizer, we will go for ADMR, gradient descent, or something like RMS prop. Now coming back to training and evaluation of the deploying model. We will train the model using the train data and validation data loaders. Next thing is model inference on the test data. At the end we will test the model using test data set. This is the whole idea of this entire project. Now let us get back to the code. Okay. In your particular Google Drive, just open a Google Colab notebook like this. Okay. Our main job is to first give the path of this particular folder. Suppose here everything every step I will describe here. Okay. First thing is data exploration step, where in this particular data exploration step I just imported pandas document. Since in the train labels.csv file I will be given the labels of each and every image. So what I do is I just use these commands like path to CSV file. Suppose assume that here in this Google Colab file I am using, just go to this stage, like suppose to give the path data to CSV file, just go to the particular folder, file name, and use the copy path. There you can type this one. Okay. This is the entire training code. Here you can see, this is to just load the data set, and you can see here we are given the file name. Accordingly we will be given the to which class it belongs. Suppose if it is normal, it is 0. If it is binary, we can say this one as 1. Okay. Next thing is I am counting how many zeros are there and how many class 1s are there. Like 0 classes are normal classes containing images and 1 class containing images. We just have done the histogram plot. Like zeros containing these many number and ones containing like 8,000 something. Like you can see here it is like 8,900 something. Okay, like 89,000. Sorry. Now coming back to here, since I have the folder full of images, I just want to enter into this particular folder and draw the images here. Okay. Import matplotlib, pill image draw. You just have to go through each and every line. And usually to draw the images or to visualize the images, we will go for matplotlib. Okay. You can see here in the code, if you see, you can see the gray images here. But in the code, you have to write something like, instead of color is equal to false, if I type here as true, you can generate all the color images here. Okay. Here I am just exploring the training data set containing how the images are looking like. Okay. All the images are in TIF format, .TIF. Similarly, we are just observing for a single image. If you want to generate color images, just type here instead of false, just true. Okay. Then you can see the images in color. Okay. Next thing is image shape. Image shape, if you observe 96 cross 96 cross 3, whereas the maximum value of the pixel is like 255, minimum value of the pixel is 0, because it is in integer format. Next thing is custom data set. I will explain to you. We are done with this one. Spot. Creating custom data set. This is very important. As I have already told you, while feeding to the deep learning models, I just have to feed the model in terms of batches. Okay, suppose assume that batch size is 80, 8 is the batch size. Let me check what batch size they have used here. Create data loader. 32 they have used. Further, so assume that I am using batch size of 32. That means I will feed the model 32 images at an instant. Okay, every time 32, 96, sorry. 3 crore 96 comma 96. Okay, this is how I do. 32, 3. Suppose 32 images containing 3 channels, where height and width of each image is like 96 comma 96. Okay, this is how I plan. So that means I will first create a dataset class. This is very important, very important, where it contains all the directories from where you have to obtain the images and everything. Here, to understand this one, you guys have to learn something like OOPS concepts. Okay, in Python, go and study about this object oriented programming. Here you will get the length of the data. Here you will get item means, suppose if I give an index of suppose assume that I have images of some 1000 images. If I given some random index of something like 1 or 2 or some 90, it will obtain both image and its label. Image X, Y its label. Both will be provided as an output if you create this particular data set. Whenever you are using Pytorch framework, I request everyone to please be familiar with this, creating a data set and this data set class and data loader. Okay, these are very much important. Okay, by using this entire class, we can get image and label. See here, image and label at a particular index. Okay, suppose assume that I have given as the data loader, I have given as something like 32 images I want. So it will go and grab all the 32 images at some random indexes. This is how the data set and data loader will work. Because in CNN models, in computer vision, often we not only in computer vision, and the entire deep learning domain, we are going to feed the data to the models in terms of batches. Okay. Now, to each and every image that are in this particular data set, I just want to apply this transform like to tensor, where earlier I shown that to 0 to 255, these will be now converted to 0 to 1 range. Okay. This is where this operation will be helpful. Just go to the data set directory, like where exactly I have kept the train data. See here, after creating this custom data set, now our job is to go and give something like this. Here, this is the train data. Okay, path to train. Here, just instead of here, data underscore directory, just go and give the train data folder. Okay, later you can histocancer data set, there you are in train, it is given. This is very important step. Data train. Now this will be treated as a train dataset class. Now histo dataset, you can assume that length is the entire training images, how many number of images are. While running in the Google Colab, it takes some time. Please have some patience. Okay, till it gets completed. Have some patience here. You can see the length of the data set is like 2,20,025 images. Okay. Now see here, hist data underscore 9. That means at some random index 9, I am just obtaining the image comma label. Okay. That image shape is 3 comma 96 comma 96, and its output is like tensor 0. Okay. And here they are printing out something like, sorry. Okay, here they are printing just image shape and torch minimum and that one. Remember that this dataset class, preparing this dataset class is very important. In any Pytorch program, irrespective of the text data or dealing with video data or images data, irrespective of the dataset you deal, this is very important. Creating the dataset class and Pytorch data loaders, very important. Next, once that particular dataset class is created, it is your responsibility now to split the data into train and validation part. Okay, because extensively they have given the test data set for us. That is why I am restricting to divide this histo data set class into two things only. Okay, otherwise you can convert if you are not given the test data set, you can even convert this one into train data set, validation data set and test data set. Okay. See here, out of 100 points, I am just converting into 80% to train and validation. I am just giving 20%. Okay. That is the code we will give. Splitted the data set. Here you can see train data set containing around 1,76,000. Here 4,400, like 20% data set for validation data. Yeah, on train data set we are just taking the loop like data set observe here. 3,1 image and its class. Similarly, from validation dataset also we are getting something like 3,96,80,0. Okay. After that, we are just taking the images from dataset, train dataset, and we are just, I will show you in notebook. Okay. This is normal step only. After creating the dataset class, we are just printing out the for single image shape and its label, corresponding label. Now coming back to this one, I just made a grid containing images related to train data set and the corresponding labels here. To get the output like this, I have written the code like this. Okay, this code is useful for to view images related to train DS, train underscore DS. Okay. Whatever DS I have created like history DS, I just have converted into train DS and val DS. This is what I am talking about. Where it contains 80% data, like this is 100%, 80% and 20%. This is how they have planned. Okay, very important. Similarly, for the test validation also, they are bringing some images like 4 images and their labels. 0, first image belongs to 0, 1. Like 0 means normal. This is like metastasis image. Remaining 2 images are also normal only. Okay, just for visualization purpose, nothing else. Now coming back to transformations. What exact transformations I am using on the train data, validation data and test data. Always remember that we use this data augmentation steps only on the train DS files only. Train data set. Okay, but not on the validation data set and on the tested data set. Okay, always remember this one. We use this data transformation, except like suppose we are converting 0 to 255 into 0 to 1. This step is okay. Okay. Other than this, any other image processing operation we will not do for validation DS and test DS. Please keep this one in mind. See here, for train transformer, like data augmentation, they are using all these steps. Whereas for validation, they just used only 0 to 255 to convert it into 0 to 1. Apart from this, everything else is common. Train DS transform, we have fed this one. Now coming back to, what sort of data augmentation steps that are required. Here, validation, we are restricting our results to only 2 tensor operation, whereas for train transform, we will do all the things like 2 tensors and random horizontal, random vertical, everything. Okay. Now coming back to creating a data loader. Here we are just importing from Torch. You can download the data loader. Here giving the dataset batches 32. We are doing the shuffling. Okay. For training data loader, we use the shuffle. Shuffle is equal to true. Whereas for validation and test, we need not keep the option as shuffle as true. Shuffle we will keep as false for both validation and test dataset classes. Okay. See here, in creating the dataset, after creating the dataset class, we can obtain for every index, we will get only image and label. Whereas after creating this data loader, see here, data loader, train DS batch size underscore 32. here we are given the output shape of the image is like 32 comma 9 32 comma 3 comma 96 comma 96 and 32. 32 indicates here is 32 array, I mean containing 32 numbers, size of this particular torch tensor, where it contains the classes of each and every image that are obtained from 32. Okay. Similarly, for validation data, they are obtaining the shape. Here for the validation data loader, they have used the batch size as 64. Okay. Till now, it should be very clear. Okay. Once you are clear with this one, while dealing any problem with respect to computer vision, it is your responsibility to create this dataset class and data loader. Okay. Please do practice how to do dataset class and data loader. Okay. It depends on how the dataset has been provided. Good. Now coming back to building classification model. Till now, we have successfully finished like exploring the dataset. This is done. Creating custom dataset is done. Splitting is done. Transforming is done. Loader is also done. Now we have batches of images. Now our job is to feed these batches into the model. But till now we didn't prepare any model. Now let us focus on building a classification model. Okay. See here. For this particular task, I am going to create convolution block 1, convolution block 2, convolution block 3, convolution block 4. Like I will have 4 CNN layers. Okay. And 2 fully connected layers. Like these are also called as dense layers. Dense layer 1, dense layer 2. Remember this one. To build the entire classification model, whatever I am going to build, I am going to use 4 CNN layers and 2 fully connected layers. Now, where exactly we have to focus, I will tell you. Okay. Here I am feeding the input with size 3, 96, 96. It is the size of the image. Okay. Here, depending on the kernel, depending on the number of filters, we will call them as convolution layer 1, convolution layer 2. Okay. Convolution layer 3, convolution layer 4. Okay. If you observe, size of the image gets reduced, whereas the depth of the image will increase. Like initially we will have 3 channel image. After convolution 4 layer, we will have several channels, and this size of the height and width of the images will reduce. Width of the image will reduce. Please keep this point in mind. Okay. After CNN convolution layer 4, we will have something shape like this. Assume that I have a shape of some 64 comma 9, not 96. Okay. Something like 24 comma 24. This is the image size, whereas this is nothing but the channels. Okay. So total number of pixels that can be obtained from here is 64 into 20. Each individual image contains 24 into 24 pixels. Likewise, we have 64 images. Okay. Sorry, channels. Channel means feature maps here. Okay. All these pixels. Now I convert this entire thing into a single vector. That is where we will use the operations called flatten. Okay. Entire 3-dimensional thing has been now converted into a single dimensional vector. That particular vector, after converting that into a single dimensional vector, assume that I have these many number of pixels, 64, some n number of pixels. So I will convert them into a single feature vector. Now I will feed this one into another dense layer. Assume that I have some 100 nodes here, and the next layer I will keep some 10. At the output, I am keeping here 2 nodes. Okay, because I am dealing with 2 classes. Okay, please keep that point in mind. In case you are going to solve a multi-class classification like 3 classes or 4 classes, there you have to keep at the last layer like 3 or 4 depending on the number of classes. Okay, please remember at the end of this convolution layer you will have these many number of pixels. In this particular case, not this 64, I am just assuming, not some n number, sir, x number. I will multiply I will make this computation and I will obtain the entire feature vector. Now we will feed that feature vector into the dense layer 1 and next the dense layer to another dense layer. At the end I am feeding to last layer. Okay, this is how the whole structure is. This entire thing I will show you how to do in the Pytorch. Whatever model I am using here is like sequential model. Please keep this point in your mind while defining any classification problem, while dealing any classification problem. This is very important. Depending number of inputs. Suppose if I use the output activation function, these three are very important. What output activation I am using, how many number of outputs I am using, what sort of loss function we should use. Since Pytorch provide all these things by default, in this code I am going. In general, people say, sir, at the end please keep a softmax activation function and compute the cross entropy loss. Okay, but here Pytorch provides something like log underscore softmax function and negative log likelihood loss. Okay, just fix to this one. Depending on this entire code, whatever I am going to show you, that code will be applicable to even multi-class classification also. Log softmax and 2 can be replaced by number of the classes and negative log likelihood loss. Let us assume these things. Okay, till now we are there. Validation, transformation done, create loader is done, building the classification model. While designing this classification model, mostly I have metrics like accuracy and loss. Okay, here some dumb baselines they have prepared to find the accuracy. This function they have created to compute the accuracy. Suppose I am feeding some 32 batch data, 32 size as a batch data, and for all the 32 images I will get some outputs like 32 outputs I will get, and I will compare these 32 outputs to my original target value and I will compute this accuracy metric. This is how accuracy metric is computed, like number of correct predictions whole divided by total number of predictions. Before that, let me tell you what is meant by epoch end. Assume that I have some 1000 data points in total and batch size is assume that batch size is something like 4. Okay, so one epoch means training has to be done for the entire data set. That means model has to be trained for all on these 1000 images. Okay, that means for every single epoch I will have each and every batch. That means total 25 0. 250 times I will do iterate. First, for the single epoch I will feed the first 4 images. I will get the output for all these four images and I will compare this with the original target variables and I will compute the loss. At the same time I will compute the accuracy metric. Okay, this is the usual step. Likewise I will do next iteration. I will give for next 4 images. I will compute the loss and accuracy metric. Likewise I will do for all these 25 iterations so that entire data set has been trained once. Epoch means training the entire data once. Batch size means batch size is like iteration. Next thing is I will obtain the loss for each and every batch. Like here I have made some functions to compute the accuracy at the same time and loss metric by using the for every batch. Okay, after for every batch I will obtain that value. For the entire epoch, what I do, I will sum up all the batch values. Once I sum up all the batch values, I will take the average and I will throw as the loss value of the entire epoch. Similarly, accuracy metric of the one epoch. Please keep these points in mind. This is what they are doing here. Just dump baseline to prepare the accuracy metric. Similarly, as I told you, to compute this value, like single feature vector, I told na, something like n, suppose assume 64 comma 24 comma 24, likewise values are came out, 64 indicates channel, 24, all these pixels can be converted into feature vector. So what I am doing is, I just have made a function, depending on the, for every problem we need not compute this one. Okay, by default a function has been developed so that you can generate this output. Okay, likewise, what is the, suppose this output will be taken out and I will multiply this value and it will be converted to this one. Instead of our manual computation, I just made a function in this particular code. See here, it gives the output after each and every convolution layer. Okay, these formulas will be there. Let's go and find out. Not an issue. Assume that for a single convolution layer, if 3 channel input and 8 kernels, kernel size is 3 and I am giving some 8 kernels, that means output will be containing 8 comma input image size is something like 96 cross 96. Okay, if I feed this image into this particular convolution which takes 3 layers and outputs 8 layers, the size of the entire thing is 8 comma 96 comma 96. This is the output. Okay, here they just have printed out only height and width of this particular shape of this particular convolution layer. In summary, this function usually calculates the output shape of after each and every convolution layer. Okay, now let us define the model. Just have some understanding of OOPS concepts in Python. This is how we will define the model. See here, input shape. For the model, I am just passing parameters only. Okay, what parameters is nothing but hyperparameters. Okay, as I told you, to let the model not to trapped by the overfitting problem, we will use validation data. On this validation data, using this validation data only, we will tune the hyperparameters so that model will not be trapped by overfitting problem. So this tuning can be done by changing several parameters. Those parameters are called hyperparameters. Okay. Here I have made a dictionary and I am passing this dictionary to the code here to this particular class model. Parameters as taken and input shape, number of filters, and first dense layer, how many nodes we have to keep. Similarly, number of classes. Okay, dropout rate is usually we will use for regularization. In this one, regularization is also concept we to use to tackle overfitting problem. Okay, likewise, I have made this entire thing. You can keep this entire code as it is, even if you solve this multi-class classification. Even you can increase the layers also wherever you want, but this code remains same. Mostly few blocks will be changed, something like, suppose if I add another convolution layer, instead of convolution 4 I will add one more layer. Similarly, I will add activation functions like this, but at the end, instead of number of classes here, I just have to give, depending, here I am dealing with the 2 classes, that is why I kept 2. Suppose if you are dealing with 4 classes, just replace this value with 4. Okay, please keep this point in mind. And suppose here I am using 3 comma 96 comma 96 as input shape, but whatever size you are dealing with the image, you can keep that size here. Okay, please keep all these points in your mind. This is where you have to make changes. And initial filters are something like, after giving the input image, how many filters I am using, like how many kernels I will use. Okay, and fully connected layer like dense layer 100. This is how we have planned. This dictionary I am sending only for the sake of hyperparameter tuning. All these things are done. Now we have defined a model using the torch. Okay, framework. See here, we just find the output size of after every convolution layer. Now model has been defined with respect to, see here, at the end we are using log underscore softmax activation function. Okay, now coming back to, in case you are using GPU, you are provided with the GPU, so now just use this command to, we have to load the model into device, like whichever device you use. Okay, suppose if you are dealing with CPU, you have to use the device CPU. If you are using GPU, you have to use this GPU device or core device, we can call. That is how for this one. Next thing is, what are the parameters like coda 0. Next thing, just checking only. From talk summary, just you have to install this talk summary. From this you can see, suppose if I give input shape as 3,96,96, what are the output shapes after each and every layer. Okay, see here, after linear 6 we are having 2. Okay, what are given as linear layers. See here, after doing this flatten operation, they are used FC1 and fully connected layer 2. Okay, it contains, it takes input as suppose 100 and 2. Okay, suppose if I want to add one more dense layer, I will give something like this one and FC2, something like that. Small change, minute changes you have to do, you have to be familiar with that one. Now we are done with the defining the models. Okay, model, and we have verified these are the outputs after each and every layer. After first convolution layer, the output is 100. Now that 100 nodes will be fed. We'll have 2. At the end, whatever at the output layer, whatever max function activation function is, logs of function they have used. That is how we design the model. Now coming back to loss function. While the training is going on, we have to observe the loss value. For the loss function, they have used the negative log likelihood loss. Please keep this one in mind. Okay, just go and verify. It is very easy, not that difficult. Here just assuming we are having some practice like how exact loss function is occurring. Okay, suppose I give input as 32 and we are having 2 classes, right? Now 32 comma 3 comma 96 comma 96 I have given as input. Now we will get output as 32 comma, since we have 2 classes, I will get 2. This is how the shape will be. If you have 4 classes, you will get output as 32 comma 4. Okay, later I will use something like argmax. That particular index value will be given as class. Suppose 32 comma 2, it will be converted into 32 containing even 101 100, like depending on the index value which has more value. That is where we will use argmax. This is how we do it. Loss function, they have used negative log likelihood loss, and the sum is reduction. Reduction means after every batch we are summing up that one. Optimizer, they have used is Adam optimizer. Second thing is, we just want to get the learning rate at the while the code is running. At any given instant, if you want what is the current learning rate, you just have to use this function. Okay, one more thing we have to Torch provide is learning rate schedule also. Suppose there is no improvement in the model validation loss after several epochs also, at that time we just either go, if you observe the basic formula, something like weight I implies weight minus learning rate into dou loss whole divided by the parameters. This is the basic equation, right? Okay, what we do here is we change the loss function, either learning rate or you have these things. Suppose if you do not observe any much improvement in these gradient values, at that time go and change this learning rate. So what we do is we use some validation loss as a parameter. Okay, validation loss as a parameter to check whether the model is improving or not. So if it is not improving, after every 10 epochs, patience here number indicates after those many number of epochs, just reduce the learning rate. This is what the functionality of this particular learning rate scheduler. Now coming back to training and evaluation. Okay, Here in training and evaluation, what we do is, as I told you, we just made a function like for every batch I will compute the accuracy metric. Okay. Similarly, I will, for every batch, using this function, I will compute the loss. Okay. Using this function, we are going to obtain the accuracy of a single batch. Similarly, we are going to obtain the loss for the single batch. Okay. Once these two are done, since device is Coda, if it is available, now our job is to compute the losses for every epoch. Okay. Epoch means number of batches, sum of number of all number of batches. Here we are computing the, for every epoch I am computing the loss. Okay. For every epoch I am computing the accuracy. Okay. Loss computed means batch loss, loss of batch 1, loss of batch 2, likewise loss of batch 2, and like that. Coming to accuracy of the batch 1, accuracy of batch 2, all these things will be summed up. At the end, we just divide with the length of the data. Okay. Suppose assume I have some 1000 data points in the entire data set. I will take up this average. That is how we will get the, for every epoch, as a summary note, I can say for every epoch, what I get is loss value, average loss value, similarly average accuracy metric for every epoch. Okay. Please keep these points in mind. Now coming back to training. Okay, loss function is done. Defining optimizer is done. Here we are using Adam optimizer, and learning rate scheduler also I am using to, if you do not see any improvement in the model training. Now coming back to training and evaluation. This one, batch loss, similarly accuracy for batch. Here they are computing the loss for the epoch, entire epoch, loss accuracy for the entire epoch. Now coming back to the training and validation. This is very important. Please keep this one in mind. What we are doing is, as I told you earlier, we just send the parameters only here. Number of epochs, loss function, kind of loss function, kind of optimizer, and data loader of the trained data loader, validation data loader, and sanity check. We use sanity check. Suppose I have made the model, instead for every, suppose 100 epochs I have kept. Assume that I have made the model and I am running the model for 100 epochs. Okay. That means in each and every epoch, assume that there are 250 iterations. Like 100 epochs I am running. In each epoch, in epoch 1, feeding data, suppose assume the data set points are like 1000, like 4 is the batch size. Likewise, it will do for 250 times. Okay. Suppose since model training without disturbing, I am just checking out whether the code is running well or not. That's why I kept this sanity check. So instead of going for all these number of 250 iteration, I am just checking that for all the 100 epochs, I will go to check for first batch, and if it is giving the value, that is, and break the loop there. Okay. So instead of going for remaining 250 iterations. Okay. Likewise, I will do for entire epoch, like 100 epochs. At the 100th epoch, again I can do like I can first batch, if it is updated, then I will break this loop. Just checking. Okay. If I keep the sanity check value as a true, that means it will go to a single epoch and it will compute all the stuff. Okay. Like 250 iterations, if it will do, it will compute the average loss, average accuracy, and will give output as a, it will return those values. Okay. Likewise, it will do, you will do for all the epochs. Okay. Sanity check false, we keep, that is just to check whether the model is running or not well and giving the desired outputs. If you keep sanity check is equal to true, that is like a true training. Okay. Where you will wait for the entire epoch training, like means all the iterations. Now coming back to how exactly they have planned this coding of this training loop. I hope everybody is understanding. If you have still any questions, you can approach me in the discussion forums. Okay. See here, what I am doing is, at the end of the training, after path to weights, after the model is, once the model is completely trained, I will save the weights of the model. That is where we are going to give the path of the model. Next thing is loss history. Train at the end, earlier while discussing linear regression demo also, I told you at the end we were going to draw the graphs like validation and training loss. See here, to generate these kind of graphs, we are going to use these values: loss history, metric history. Okay, this is the accuracy metric, this is loss metric. Please keep that in mind. After every epoch, whatever the average loss value I got, I will keep this one as the first entity. Similarly, accuracy also I will keep in the second entity. Validation loss also, validation accuracy also. Likewise, I maintain two lists. Okay. Best model weights. Keep the model state dict. Okay. To load the entire training model, I am just here. Assume that epoch number, and it will give the current learning rate. Like outputs will be like this. We'll show you. This is how it is. To generate while the model is training, your job is to keep these values, trace these values. Okay. Current learning rate, whether best model weights are copied or not. This is depends on the validation loss. Okay, I will show you where exactly that condition is used. Sometimes, as I told you earlier, we are using the learning rate schedule. We are reducing the learning rate also if there is no much improvement in the model. At that point of time, once the learning rate is reduced, I will use that strategy or use the model weights. What are the best model weights till that time? Suppose after 50 epochs, the model has reduced the learning rate to some another value. At that point of time, till the 50 epochs, I am going to save the best model weights till the 50th epoch. Okay. Once that is done, I mean this learning rate is reduced. At that point of time, this model is again loaded with the best model weights. From there, I will start the training with the new learning rate. That is the whole strategy. I will show you in the code where exactly I have written. See here, it is our responsibility to keep the model in terms of train. Okay, train loss, train metric using this function. This function is defined above. Okay, and after that, train loss and train metric will be taken into this one. Similarly, now coming back to model evaluation mode. In this mode, we don't send any optimizer and all that stuff. At that time, we want all the no back propagation, nothing we should do. No update of weights and everything. We just feed some data in terms of batches in validation loss, and I will take the output. Okay, and I will compare the loss and everything. That is how we should do. Other than that, nothing else. Okay, I will trace here validation loss. Okay, and validation accuracy. Assume that till that time, assume that I have my initial value of some best loss validation loss is some infinite. Suppose at after several epochs, after 2 or 3 epochs, my validation loss is less than this infinity. Okay, that means it is a better validation loss only. End of the day, I need very less validation loss. Okay, so at that point of time, I will just save the weights of that particular model. Okay, after again okay, assume that. I will show you. Assume here, after first epoch, we can see that validation loss is less than infinity. So they are copying the weights. Similarly, after first epoch, same. Suppose at that time, whatever validation loss I have, I will swap that value to, I will assign that value to best validation loss. Okay. After second epoch also I will get the validation loss, and I will compare this validation loss with the earlier validation loss, which I have stored earlier in the best. Okay, so That is the logic I have used. Suppose if that new validation loss is less than the previous validation loss, again I will save the weights because those are good weights. Similarly, see here, copied best weight, copied best weight, copied best weights, copied best weights, copied best weights, copied best weights. Okay, after a certain number of epochs, you cannot see that one. See here, till 18 epochs it is good. After that, there is no such printing statement. That means there is no much improvement in the validation loss compared to earlier validation loss. Okay, that is the logic I have used. Next thing is, I am explaining each and every segment so that you will get to know what is the importance of each and every thing. Okay, see here, that is how I am doing here. Next thing is learning rate scheduler step. Okay, suppose the new validation loss after several epochs also there is no much improvement in the validation loss. Here I have given the patience as 20. I mean, it will wait up to 20 epochs. If that validation loss is not improving, at that time they will go and reduce the values to some lesser learning rate. Here I have used some half of the learning rate of the previous learning rate. Then at the same time I am going to load the best model weights. See, I will show you. Train loss, train loss, train loss, train loss. See here. Okay, in some of the cases we can see that best model weights loading also. Okay, likewise we will do the training where by using the validation loss, I am just checking out how exactly my model is good or not and saving the best model weights at every instant. While reducing the learning rate also, what I am doing is I am loading the model with the best model weights till those number of epochs, and I will again start the new training. It happens automatically. Okay, that is how the entire code has been written. At the end of the training, you will have losses for each and every training loss list. Similarly, you will have validation loss list, training accuracy, similarly validation accuracy. Using these 4 lists, you can generate the graphs. Okay, that is the whole idea, and at the same time you will get the models weights also stored. Okay, see in the training loop, the model will be given as output written like CNN model, loss history, metric history, everything will be assigned. Okay, metric means accuracy only here. That is how we will use. Okay, see here, first what they have done is sanity check is true. That means they are just checking, go to each and every epoch and first do the training for first batch and update the weights. Okay, similarly they will do for the next batch for the next epoch. Likewise they are restricting themselves to first batch only. Next the original training starts. See here, only this is a sanity check only. Okay, and after the sanity check they are plotting the plot. Usually we will assume the plots to be something like this. Suppose if it is validation training loss, validation loss should be something like this curve. This is where the point of interest. Okay, please keep that point in mind. Accuracy is just like that. Okay, some basic difference will be there. Maybe the plot is wrong. Okay, now coming back to, see here, sanity check false. That means we are now allowing the entire model to train in a proper way. It will go to epoch 1 and it will compute the loss for first batch and metric for first batch, go for second batch, compute the loss and metric, go for third batch, compute the loss and metric, go to the batch 4. Likewise you will do for every batch and compute the entire loss. You can see like this. Now you will obtain the graphs for both training loss and validation loss. Next your job is to, once this is done, you can save the models. Once this is done, what is the step? Now the training is done. Suppose assume 100 epochs. they have done for 100 epochs. Sorry, see here they have generated only for 2 epochs. You can keep this value as 100 and train this model. After 100 epochs, you will get to see the best model weights, and those model weights can be used for testing purpose. Okay. You can change this value, number of epochs, or what we say, mostly this one. And learning rate scheduler also, go to learning rate scheduler function. That is the starting value, I think. You can even change that value also. Learning rate scheduler, see here, you can change this value also. Okay. Like optimizer, OPT they have given, I think. Optimizer is equal to opt. Okay, you can change that value also. These are the things we call as hyperparameters. We will tune the model. Till now we have done the training part. This is how the code has been done. Okay. This is for sanity check, this graph, whereas these two graphs are for after entire training. But they restrict themselves to 2 epochs only. That is why it is showing here like this. But you can train this model for 100 epochs, and you some more depending on your capacity, okay, or computational facility that you have, you can use this stuff. Now we can say training is finished. Training is finished, and we have saved the best model weights. Okay. Next we will concentrate on testing of the model after deploying. Now let us focus on test data set. What we have done is model has been trained, and the best weights are saved to a particular directory. Okay, directory in the sense one folder I have kept for loading this model in my Google Drive, where this entire directory is present. Then the model will be saved. I forgot to mention, all these codes and everything, notebooks, Jupyter notebooks I am using are from, there is a by Pytorch for computer vision book. Pytorch for computer vision book. Okay. By Michael Evande. He basically works in medical image analysis. All his the Jupyter notebooks belongs to this particular textbook are already kept in Google. I will show you. GitHub. Pytorch for computer vision by Michael Evande. Okay. If you go to this one in chapter 2, these notebooks I have taken and explaining them. Not only for this one, this book gives you something like a basic understanding. You can go and use those Jupyter notebooks depending on the binary classification, multi-classification, and something like segmentation tasks. Everything is provided in this particular book, where you can use that codes for your, you can modify those codes according to your usage also. Okay, just for the sake of information I am saying. Now, coming back to deployment stage or testing phase. We have to, before loading the model weights, we have saved the model in terms of state dict. We call state dict. In Torch it is available. It's a kind of strategy we will use in terms of this particular format. Okay, whatever I have developed before training the model, the same thing I have done here, like calculate the output shape for after every convolution block. Later you can see model has been defined, convolution layer. Usually in terms of layers we call convolution layer and full dense layers. All these max pooling layer and activation function on the layer, all these things cannot be called as layers. Only these are convolution layers. Max pool operation, everything is done. Model has been developed. At the output layer I have used save loss function, like activation function like log underscore softmax activation. I have already discussed this earlier. Next thing, the parameters here. See, input shape is this one. Here we have removed the optimizer, we have removed. Number of epochs we have removed because we are not doing training here. We are just testing. Suppose if I use input image, and it should predict the output, like to which class this particular image belongs to. Which class? That means if I give the input as this one, it should give me the output as a label, whether it belongs to 0 or 1. That is the whole idea. So dropout rate and number of fully connected layers and number of classes. Okay. Model, net of parameters model. See here, wherever I have saved the models, I just have to give the path from here, this particular path, and see you give that path .pth file. So the models will be loaded using this one. Now the model has been loaded with the best model weights. Best model weights that are obtained through training. Okay, please keep this point in mind. Now please keep the model in evaluation mode, not on train mode. Device, whatever device you have, suppose GPU, then please use this command. Now coming to deployment. This function they have created just to obtain the number of predict the output in terms of NumPy format. For the given any image, it predicts the output. Similarly, ground truth value also. Okay. For the dataset, we will send the test dataset. For the test dataset, we will send the test dataset. Okay. It just computes the average time it has taken to compute the inference to compute the value. See here. Depending on the dataset I send, LN of the dataset it will take, and depending on the number of images I will send. Okay. We will just predicting the output. Next thing is create the test dataset and see here, test dataset we are creating. We are not creating in data loader. Okay, that is up to you. So if you create data loader, you are restricting yourself to 64 images, something like that. But here I just want to predict some random indexes of images, and I will get its output and everything, and I will compare with the ground truth. Okay. But here in this case, they didn't provide any ground truth values for the test data. We just have to predict, and we have to submit these values to the competition. Okay. Random split. See here, train data only, validation data minus validation data. First here we are checking using the validation data set itself. Validation data set only. Sorry to say. In the code they have written like that. First validation data set they have, because validation data set doesn't involve in training actually. Training doesn't involve training in the sense we don't compute the loss values. I mean, we don't use validation data loss values in terms of updating the weights. Okay, like in back propagation stage we don't use the validation data set. That is why we can use this one as a test data set, just to, because validation data set has this ground truth values. Maybe that is why they are using. If on the test data we don't have ground truth in this particular case, maybe you can test later on whenever test data set is provided. Here we are just using the validation data set only, just to predict the outputs and comparing with the ground truths. Maybe that is why. Train data set length is this one, and validation data set length is this, like 176 and 44. Maybe I will send these things now. Deploy model, CNN model, validation data set. Now we have sent the entire validation data set, like all these numbers. Okay. Now if you observe the output shape, it is outputting the values like 44, 44, 5, 2. That means because we have two classes. Okay, that is why it indicates. Suppose you have 3 classes, it indicates 3. For every prediction you will have 3 points. Every prediction you will have 3 points. And on that we use the argmax function. It is very helpful. Argmax function is very helpful. We regularly use. Okay. Please make yourself comfortable with how to use this argmax value. Okay. On this one you can see, now I have, suppose I will give you example like 0.5 or 0.6 or some 0.4. This class belongs to 0, this class belongs to 1. At that point of time, I will np.argmax will return the value as 0. In case the values are like this 0.4 and 0.6, at that case, np.argmax will send the index value as 1. I mean, it sends the index value at which the maximum value occur. Okay. After that, from this value 44005 comma 2, now the obtained value is 44005, because using argmax we have predicted the labels. Okay. Okay, here they have done for, and they have computed the accuracy also. Okay, that accuracy value is 94%. That means they have tested the model on validation data set only till now. On the test, sorry, I have told you earlier test data set. We will go for test data set later, but first they have computed the loss on the or accuracy on the validation data only. Validation data set has been given as an input, and we have obtained the outputs, and it is giving a compared with the ground truth values, and now the output is 94%. This one we have done on GPU device, I think. Now they are comparing with the values on CPU also. Okay, that's it. There is no much difference. No need to discuss also this stuff. Now coming back to model inference on test dataset. Since on the test dataset we don't have any we don't have any ground truth values or the original values of the outputs to which class it belongs. So we just have to predict the outputs and have to similarly and send the data. Suppose this is how it is been given. Just make the test dataset class here, histo dataset. This is out, and deploy the model, and you can say np.argmax, and you got that this one also, and you can you need this function. After this, you can even compute the accuracy also, how we have computed on the validation dataset. Okay, but to do so we need ground truth, right? So we don't have, so we cannot compare those values. Okay, but we can predict the values. I mean, what class it has given, like 0 or 1 or for everything. Okay, so suppose in case we have 57458 test images are here. Now we have a 5457458 output array containing single dimension where all the values are 0 1 0 1 1 1 1 0, like to which class particular belongs. We are just predicting using our model. That's it, nothing else. Here you can see all the original images. Maybe you can see the why they are gray means they have just replaced this color value with false. See here, if color double equal to false, they have written this one, else this one. Okay, that is the basic difference. This is how we will train the entire classification model using the basic sequential network I have used here. You can even go for transfer learning where the model will converge faster. That's it. You just go and verify on the internet and check out the details. Here you guys need not concentrate on this one. Till here we can discuss more than enough. Okay, thank you so much for the lecture. One more thing is like in the entire project what we have done, I will as a summary note will give you idea. The basic program is our task is to, suppose if we are given any 96x96 patch image to the trained model, it should give the output either as a 0 or 1. I mean, either it belongs to normal image or it belongs to malignant image. This is what it does, entire thing. For that we have to develop the code using the Pytorch framework. Dataset download is the first thing, where I have using the Kaggle compilation I am using, and download the dataset using these following steps. Later, these are the key topics one has to go through to design the model. After that, we want to design this model like convolutional neural network. Next, this is very important step, like how many nodes you have to keep depends on the entire code. Whichever I have given now, this one can be useful for multi-class also. But at the same time, in the training label files, instead of 0 1 2, assume that you have 3 classes, then you will have labels like 0, 1, 2 also. Okay. Suppose you have 4 classes, 0, 1, 2, 3 labels. Okay. That is how we should prepare. Let's start it. Then this entire code can be used there for your problems, whichever you use. And optimize the definition and everything, all these things are done. Thank you so much.